Start the recording. All right. So this last chapter, we went over sensation. We're in sensation and perception. This past week, you learned about sensation. And you learned specifically about the various sensory organs. Again, what do the sensory organs do? What is their purpose? Eyes, ears?
Receive information.
Okay, they receive information. What does that mean?
Like they get the physical signals and then turn them into electrical signals that our brain can use.
Very good. So physical signals like what? And someone else. This is Michelle or Ambrosia. What physical signals are we talking about? What physical signals are we converting into an electrical signal? So what physical energy source does your eyes convert into an electrical signal? What are you converting? Or your ears, or anything.
Are you talking about like the like sound waves, light waves, and
Exactly. Yeah. Light waves are actually a physical object out in the world. They're bouncing all around us. We can't really, I mean, we see them technically, but you can't really like, oh, there's a light wave right there. But they are there. And for us to see, we have to convert that light wave into something that our nervous system understands, which is electricity. Our nervous system deals in electricity. Electricity is its currency. It is its language. So we need to do that. That's what the sensory organs do. So I really want to nail this home, and I want to review this just a little bit. I understand that you already took an exam on this topic, but I think we can go a little bit deeper. I want to make sure that this connection is there. Because I'll be referencing sensory organs and how energy sources are converted into electricity for the rest of the semester. So we do convert energy into electrochemical impulses. And first thing I want to say is to remember that when we talk about an electrical impulse or an electrochemical impulse, we're talking about an action potential. We're talking about this thing on the right side here. Talking about how the inside of the neuron becomes really positive, then it becomes really negative, and then it goes back to that resting state. That is the electrical impulse. So we're converting light into that thing. We're converting sound into that thing. So someone explained for me, let's try to take this step by step. How do you turn light into an action potential? If someone asked you that, say, you know, crazy example, but imagine that question popped up on the comprehensive exam. How would you answer that? How do you turn light into an action potential? Trace that path for me.
Am I still in timeout?
No, go ahead.
And we're talking about light specifically?
Yes.
Okay. Well, our eyes take in light through the cornea, your iris, and pupil, and the images are kind of like flipped onto the back of your retina. And your retina has the cones and rods that have the power to transform that into the electrical chemicals because they're like photoreceptors. Is that what they're called? You
got it. Yeah. Yes, and I want to emphasize this point. The sensory organs are the actual physical collections within your body that house the sensory receptors. It is the sensory receptors that turn that light or that sound or whatever into an electrical impulse. It's the organ that kind of organizes them. Makes sense. So the eye is an organ because you need all the parts of the eye to get the light in there, to focus it, and to have it be processed in the retina. But it's really those sensory receptors, those photoreceptors in the retina that do the heavy lifting. Those are the ones that convert light into electricity. Okay, good. The light comes in through the cornea, through the pupil, hits the back of the retina. The image is flipped, and that light gets picked up by cones. And what are cones versus rods responsible for? Michelle, I'm going to pick on you. What are cones versus rods responsible for?
I'm sorry, I can't hear you very well.
Oh, no, really? Is it, I'm not
No,
sure.
it's me.
Oh,
I just couldn't hear you.
I see. You actually know, I do see that your connection is just a little bit in red. But so I was asking, what are cones responsible for, and what are rods responsible for? What do each of them do? I think your connection might be. I'm hearing static. It's okay. It's okay. Sit back, relax. This is another one of the difficulties of this kind of format. So cones are responsible for detailed color vision. Rods are responsible for just light sensitivity. But each of them, both of them are photoreceptors. They're sensory receptors converting light into an electrical signal. All right. How do we turn sound into this action potential? This is open. You can answer too, Savannah.
Sound. It's
Yes.
mainly in the cochlea where the vibrations end up going through the external auditory, canal to the eardrum, and then that moves the little ossicles, bones,
Ossicles. Yep.
ossicles that thump on the cochlea, and that causes vibration to go all through the tubes and then back down, and that kind of activates the. I remember it was like hairs or something.
Mm-hmm.
There's some sort of bendy thingies that thump.
Yeah. So that cochlea is actually full of a liquid, and you're passing vibrations through that liquid, and when that liquid is vibrating, it presses on the walls of the cochlea, and there's an area in between. So you know how the cochlea is spiral shaped. There's an area between between the canals within that spiral, and that area in between gets stimulated. And inside there, the stimulation causes certain little hair fibers to actually press up against the wall, and that generates the electrical impulse. Yeah. The hearing is actually, I don't know, I find hearing fascinating, to the complexity by which we convert these signals into electric is it's hard to believe sometimes that we're that complex. Yes. Okay. And then in terms of taste, I'll not put you on the spot the whole time, Savannah, but in terms of taste, remember that we have these actual receptors tucked away inside of our tongue, not those bumps on our tongue. Those are papillae, but in between each of those papillae, we have taste receptors, and when food gets digested, they go inside in between those papillae, they go into the taste buds, and then the taste buds convert it into an electrical signal. Again, creating an action potential. With touch, you have receptors all throughout your skin that are specialized for texture, for pressure, for temperature, and you do have specific receptors dedicated to pain, funnily enough. So you could be able to touch things, feel things, have those sensations, and yet you could be, say, missing your pain receptors such that you don't feel pain in a certain area. Some people have this where, if they suffer a really traumatic injury, such as like a burn, right, where they actually burn away certain receptors, they can lose the sensation of being able to feel pain. in certain areas of their body, which sounds amazing to some degree, but of course, pain prepares us for what's about to happen after you feel pain. So protects you. All right. I really wanted to hit that home for those who don't quite haven't made the connection between sensation and everything that we had talked about before. This is the connection. We are turning these sources of energy into that electrochemical impulse, this action potential that we then pass along. So if we were to visualize this, we have an action potential, and that is the thing that gets passed down the axon. That's the thing that we're communicating between neurons. And when it gets passed down the axon, remember that at the very end of the axon, we have those neurotransmitters that get released. Because of the action potential, they bind to the next cell, they generate their own action potential, and the signal keeps being sent. But it is through this process of continually stimulating that connection that we then produce long-term potentiation, right? Continually stimulating, having that action potential release those neurotransmitters increases the activity. The more the activity increases, the stronger the connection becomes between that neuron and the next neuron. And that is how we learn. That is how we form memories. Our memories are these connections and how strong these connections tend to be. Can we re-stimulate these connections to recreate the memory that we have? All right. The next part of this class is perception, second half of the chapter. And this is, I think, this is the part where we need to make a really big jump. We are now moving from kind of these microscopic processes, which really we're not going to tap into anymore. I'm going to, from here on out, assume that everyone understands what an action potential is, how it gets passed, how it causes long-term potentiation, and how long-term potentiation leads to learning and memory. Then, of course, how sensations create those action potentials. We're going to be taking that and we're going to be leaving it behind. Of course, I'll talk about it, but I'm not gonna label. You realize the past several discussions, I've been belaboring these points. I've been jamming them into you. You don't have to worry about that anymore. I won't be referencing back. But we will be using those concepts, so I'll expect you to understand them. If you don't, make sure that you reach out to me and let me know. It'll be essential. Our next step beyond perception is we're going to start talking about consciousness. We're going to talk about the effect of drugs on the body, and especially when we talk about drug dependence, you're going to have to understand how axon terminals work, because drug dependence is learning. It's learning that certain drugs lead to certain outcomes, and some of those outcomes are really pleasurable, they're really desirable, and we want to repeat those outcomes. So please make sure that you are familiar with everything leading up to here. So perception is now going to be the process by which we take all this information that we're gathering with our nervous system and we make sense of it. The first step that I'm going to focus on for this upcoming week is that whenever you're trying to perceive something, when you're trying to make sense of something, what you have to do, what your brain has to do to understand it, is it has to make some assumptions about what's true or not. So your brain is not just this kind of fluid, okay, you just put information in and then it knows that information. The brain actually comes pre-equipped. When you were born and this thing started to develop, it came pre-equipped with a number of assumptions or ways of processing information that are consistent across all people. No matter where you hail from, no matter what country you're from, culture, there are certain ways of making sense of patterns that is ubiquitous. It is universal to all people. That's what we're going to start talking about, is how does what assumptions underlie people's perceptions of or how they make sense of the information that comes in through the nervous system. So we talked back in the biology chapter about how you have this cortex. It's the very outside layer of the brain. I said that it was, the most complicated part. It was at least this is the most well developed compared to, sorry, it's the most recently well developed compared to other aspects of the brain. And what these parts are largely responsible for is perception. So you being able so if you go down to the very basic stuff in the medulla, just breathing and heartbeat and knowing when to fall asleep and how to coordinate motor movement versus the middle stuff, motivation and emotion, thirst and sex and learning, long-term memory storage. These things are kind of really basic. They're relatively automatic. When you get to the cortex is really what's going to be responsible for giving you this personal experience of what's happening in front of you. So when you're listening to me right now, you kind of have this subjective experience of what it's like to listen to me, to hear what I have to say. Or if I wave my hand on the camera, you kind of have this experience of these 5 fingers and this thumb and this palm waving in front of you. There's a personal experience that you have. The cortex, the recent developments in the cortex relative to other animals is really what gives us that unique ability of kind of like sitting back and kind of having this subjective experience. That is perception. That is what we're talking about. When we say make sense of the sensations that are coming in, we are trying to create this subjective experience of feeling like, for example, we'll go over depth perception, feeling like when I put my hand in front of my face like this, how do you know that my hand is in front of my face? Well, you know that it's obscuring my eyes right now, but you need to make certain assumptions about what is true to be able to have that perception. So one of the assumptions we make is if one thing is obscured by another thing, then the thing that is obscuring must be in the foreground. It must be in front of. And the thing that is being obscured, that's being hidden, must be in the background. That's a pre-built-in assumption that your brain has. Can you, if you really, I try to introduce this as best I can, but this is very complex until you kind of actually see the lectures. But do you feel like there are any other assumptions or things that your brain does that almost every other human's brain does, or maybe even dogs and cats, non-humans do as well? It seems like a really basic ability that the brain must do to make sense of light and sound and touch and all that. Do you feel like there's can you think of other really basic things that your brain has to do to understand the world around it? Either of you have kind of an intuitive sense about that? What does your brain have to do to make sense of the world around it?
I want to go with a simple answer like learn or memory,
True. So it has to build those connections in the first place. And that's going to be due to experience. What I'm talking about is the stuff that's pre-built into you. Learning and memory, you acquire those through experience. Being able to tell the difference between what is in front of you and what's behind something else is something that pretty much every at least human will pick up even without experience. You need enough experience to be able to see, so your how well you see is actually dependent on visual experiences that you have, but your brain comes pre-equipped with this ability to kind of tell what's in the foreground and what's in the background.
So like the kinesthetic sense?
Okay. How so? Yes, to some degree, yes. Yeah, actually, yeah. So being able to know where your body is in space at any given moment would be something that you inherently have. Sure. Yep. Yeah, that'd be a good example. We'll learn about few other abilities, such as 3 dimensions. So when you're walking through space, how do you know that how do you know that you're actually in a 3-dimensional space? Imagine a world where you live in a room and the walls of the room are painted in such a way that they look like they're 3-dimensional, but they're actually not. How do you trick the brain into thinking that a wall is 3-dimensional when it's not? Or when you look at a picture, the picture is 3 dimensions. For example, this picture that's right in front of you, this brain, it looks 3-dimensional. What cues you to perceive that brain as 3-dimensional? It's actually a 2-dimensional image.
Shadows.
Mm-hmm. Yeah, good. We have some intuitive sense of if light hits at a certain angle, it will cast a shadow. You don't have to be taught that. That is something that you will generally become equipped with. You may notice the pattern and the pattern becomes stronger, but it is an intuitive sense. Yeah, lighting too. I mean, there are certain, in this brain image, there are certain parts of the brain that seem to be reflecting light, kind of like you'd see like light being reflected off of water. And that kind of gives some amount of 3 dimensions as well. So lighting is big. How else do you know that this thing is 3 dimensions?
When you say this thing, you mean the photo we're looking at?
Photo. So the photo itself, of course, is 2 dimensions, because it is just a photo. You have this perception that the brain depicted in the image is of 3 dimensions.
I was gonna say depth perception.
What leads to that? Like how do you know something has depth? You're right. It is due to depth perception, but how do you know something has depth? Shadow is one of them. One is kind of one assumption that your brain is pre-built with. If something has a shadow, it must be 3D. If you look at how the brain is cut, there's a right hemisphere and a left hemisphere. You can kind of see that the right hemisphere is portrayed behind the left hemisphere. So to some degree, you're going to assume that this thing must be at least layered, if not circular, because you can see that there is a right hemisphere that lies behind the left one. So there's overlap there. Overlap is a cue.
I was thinking like maybe like their position in space compared to other objects.
Ah, okay. Yeah. Yeah. I guess in this photo you really only have the other part of the brain to compare it to. Michelle, you opened your mic. You were going to say something. I think I may have cut you off.
Oh, I was gonna say like how the brain's positioned, the right hemisphere behind it, and the hemisphere in front of it. So
Right, exactly. Yeah. Yep. These are some of the assumptions that your brain has. But that is what we're going to focus on, is by default, how does your brain organize information? We do really complex stuff as humans. But the basis of all of our really complex stuff, there are really, really basic perceptual assumptions that we make. And I want to prepare you for the fact that we're going to be going over assumptions this next week. Okay. All right. So again, if sensation is taking in information, perception, another way to look at perception is that it is the higher level output of sensory processing. That is, if you have sight and sound and taste and texture all coming in at once, each of those things is meaningful. But we put them together in this unique way that we create something entirely new from combining those different pieces of information together. That makes it what's called higher level. I'm not sure if either of you are familiar with the idea of emergent properties. Have either of you ever heard of that?
Not in terms of perception, I guess, is the best way to.
Where have you heard it?
I think I might have heard it in my biology class before.
Mm-hmm. Mm-hmm. It's common in physics too. So if you look at atoms and the way that the atoms behave is considered an emergent property.
Oh, so I heard chemistry.
Oh, yeah. Yeah. In chemistry too. Physics, chemistry, it's all related, of course. But yes. So electrons behave a certain way, protons behave a certain way, neutrons behave a certain way, and each of them individually can do something. When you put all three of them together and you create an atom, atoms are capable of things that each individual particle is not capable of. When you get an atom, what you can start to do is string them together to create compounds, which the compounds then have emergent properties. Things like water is a compound. You string three different types of atoms together, two hydrogens, H2O, two hydrogens and an oxygen, and you get this new thing that really has its own properties. It's now this wet water that's a neutral, slightly acidic foundation for many different things. So you are creating this new emergent, this higher level output from combining lower level pieces. So you're combining the proton, neutron, electron into an atom and being able to combine atoms into something bigger, and then being able to combine that bigger thing, water, combining water with other types of compounds to create even more new things. Your brain does the same thing. Perception works the same way. You are taking these electrical signals that you've created by converting light, sound, etc. into something, and then you're creating something entirely new out of those electrical signals. I think that's the really cool part about the brain. I think that's the cool part about perception. So our goal this week is to figure out, how does your brain accomplish that? How does your brain interpret sensation? All right. Now that I've blasted you with all of that, questions about upcoming week, what my expectations are. I actually, just so you realize, I have not yet uploaded the videos. I had to make a last-minute change to some of them, so those will be available probably within the next half an hour, but they're not quite up yet. But any questions about the class overall, concerns? I did get I believe in this class, I was able to grade all of your research proposals, so you should have gotten that back.
We didn't have a hypothesis to do, but we do have one next week, right?
I believe it's next week, yes. I believe it's next week. Let me...
Yeah, I finished the exam, and I felt like there's something else I needed to do, and I was like, do I have a hypothesis? So I started panicking, and I checked, and I was like, I don't think so.
Yes, next week.
Back in my mind.
My intended strategy here is I want you to... If I've trained you to write hypotheses well, I now want you to go through extinction a little bit, and then we're going to pick it up again. So yeah, there's a little bit of a lull in writing those hypotheses. It's intentional. All right. Other comments?
I haven't gotten to look and see what you said about my research proposal yet.
Sounds good.
So maybe I'll get back to you in an email about what you meant.
Sounds good. You actually you both did quite well, so shouldn't be too concerned about it. But sounds good.
How much because you showed a video inside of your video about the ear, learning how it works. You said we don't need to know all of it, But so what you wanted us to learn was like the pathway. Is that what you wanted us to get from it mostly?
Correct. And for the comprehensive exam, that'll be true too.
Okay.
Not so much the nitty-gritty of the anatomy. I'm more interested, do you know how light gets, or sound gets turned into an electrical? What's the pathway by which sound gets turned into an electrical impulse?
Okay. And I noticed on one of the exam questions, it asked us the pathway at which we interpret light, you know?
Mm-hmm.
And it said, I think it went like from the best answer was like cornea, pupil, and then lens and retina. But it just completely skipped iris. Is that just because iris is the muscle?
It's because there were, I gave 4 structures they had to put in order, and I think sometimes I included iris and sometimes I didn't. It was more of me just standardizing that there were 4 options. So yes, technically you pass the iris, which then leads into the pupil, which then leads past the lens, but I just didn't put it there. That makes sense?
Yeah. I didn't know if there was a reason behind it.
There wasn't. It was more arbitrary. But hopefully the order was clear. You probably got that one right.
I guess my other question could be, when you say the comprehensive exam,
Mm-hmm.
is there going to be a question like you've asked us in the discussion where you say like, how does this all relate? And you have to like try to come up with a long paragraph that puts every topic into it?
Everything will be multiple choice.
Oh, okay.
Yep. Now, I will warn you though, my comprehensive exam is almost exclusively made up of narrative questions. So there's no simple question of like, what part of the brain is responsible for thirst? Something like that. It'll usually be, I'll present a story to you and then I'll have you critically analyze that story and give me an answer to.
Like, Monica's been exercising for the past 5 hours.
Exactly, yes.
Water. What's controlling that?
Exactly, right. Stuff like that. Yeah. So it's I see this kind of like bigger picture understand the stuff that we get at discussion, these bigger picture understandings of how everything relates is going to be helpful. It's just you don't have to write about it, but you will have to be able to interpret. I see. So the point of these, I mean, what you should be able to do is take what you've learned in this class and apply it to your real life. Troubleshoot is my intention. And so what I'll be doing is I'll present these narratives that you then have to troubleshoot with the information that you've learned in the class. That makes sense. I think it's probably the best way to use this information and learn it. Also, I tend to give a comprehensive study guide, just so you know.
Oh, cool. When is the exam?
The comprehensive, I'm not sure. I want to say it's something like the first week of December, the first or second week of December.
I'm sure the syllabus says.
It is. It's. I want to say it's on the 9th or something like that. It's on the 10th. It's on the 10th. Well, I should say it's due by the 10th. I have not yet decided how I wish to administer it. I'll probably do it the same way I've done it for these exams, where I give you a week to do it.
I found it. Due by 5 p.m. I think that's all that I had at the moment.
Great. All right. Well, this is a relatively light discussion, so what I'd like to do is I'd like to just open this up for you to do your research participation. If you have not done it already, here is more time for you to do that, and of course, maybe get a head start in your hypothesis for next week. If you have any questions, you know I'm always available, and I will make the recordings available sometime within the next half hour. I'm still waiting for YouTube to process them correctly. So.
Oh, and the other professor hasn't put up any of her research?
She has not. She has not gotten back to me. There is, I wouldn't bank on this, but there is a remote possibility that she will not be able to do the in-lab stuff. If that's the case, then of course we'll change the requirement.
Okay.
Yep. For now, assume that we will, and in the meantime, just do the online stuff if you haven't already. I think you have. I got yours.
Yep.
All right. Well, thank you for being here. Go do some research participation, and I will see you next week.
See you next week.
All right. Thank you. Take care.